Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths A. We started a discussion with our basic chapters, complex numbers, de Moivre's theorem, and also we did quadratic equations, right? Fine. With the continuation of these basic algebraic things, we are going to start a new chapter, that is theory of equations. What is this theory? What do you mean by this particular chapter is when it comes to our algebraic part, we started how to solve, how to prepare an equation. Yes, we learned factorization. Yes, we learned the sum and product of roots of a given quadratic polynomial, and we also know how to solve a polynomial of degree 3, even of degree 4 also we learned in our lower classes up to 10th. Isn't it? Now first tell me, what is a general polynomial? A polynomial can have a degree 1, 2, 3. If it is 1, so it can be linear, binomial, trinomial, polynomial also. So a function can have a degree of power n. Let us say it is like ax power n, a2x power n minus 1, a3x power n minus 2, and so on up to an minus 1 into x plus an into x power 0, one constant. Okay, which includes all the coefficients of x terms and all the powers of x. Clear? This is a polynomial of nth order. Right? Fine. What do we used to learn for this given polynomials? For a trinomial or a binomial, simple quadratic equation or a cubic polynomial, we used to find sum and product, if you remember. Right? So, how did we derive it? How do we solve it? Let us say I have two factors or two roots, alpha and beta. Okay, so what will be our equation? X minus alpha into x minus beta. If I multiply, I will get it as x square minus alpha plus beta into x plus alpha beta equal to 0. Is it? So from this, if ax square plus bx plus c is equal to 0, if I take a common, I will get it as b by ax plus c by a. If I compare it with, I will get sum of roots as minus b by a, product of roots as c by a. Yes, if it is a simple quadratic polynomial. What if it is a cubic? What if it is a degree 4? Okay, those all things and how to solve that. And we also used to learn like one factor is reciprocal of other. So what is its product? How do we find those roots? By giving those all, we are going to solve given polynomials up to degree 6 in this chapter. Okay, is it clear? Did you understand what all we are going to learn? The basic. First we will learn the sum and roots of a higher order up to 6. That is, we know only up to 2 or 3. 3 is also rare for you. So we are going to learn all those. Okay, then we are going to learn how to solve a given polynomial of higher degree. Fine. And we are going to solve when the given roots have some kind of relation. For example, one is mean of other two, like that. Okay, shall we start the chapter? Let's do. Look at the question here. He gave us to form a polynomial equation for these questions. How do you form a polynomial equation? If I have two roots, I used to write it as x minus alpha into x minus beta. If I have three roots, how do we solve it? Just let us write it as x minus 1 into x plus 1 into x minus 3. Is it? Just writing it in the form of a standard equation. Done? Is it okay? So let us solve it. X minus 1 into x plus 1 is x square minus 1 into x minus 3. If I multiply this, what do I get? X cube minus 3x square minus x plus 3. That's it. Is it a cubic polynomial? Right? Fine. Look at the next question here. How many factors are there? 0, 0, 2, 2, minus 2, minus 2. There are 1, 2, 3, 4, 5, 6 roots. So let me write it as x minus 0, x minus 0, x minus 2, x minus 2, x plus 2 into x plus 2. Is it? Fine. Now x minus 0 into x minus 0 is x into x. Now x minus 2 into x plus 2 is x square minus 4. Here again x minus 2 into x plus 2 is x square minus 4. Is it right? So let me put x square outside only and let me multiply these two terms. X square into x square is x power 4 minus 4x square minus 4x square plus 16. Is it? So this goes like x square into x square minus 8x square plus 16. If you want to multiply, this will be like x power 4. Oh shit, this is x power 4, right? Now 4 plus 2 is 6. Now here it is x power 4 plus 16 x square. This is my polynomial of degree 6. Right? Good. Look at the next question here. What are the factors here? 1 plus 2i and 1 minus 2i. See here, this is the first question with which we are going to form a polynomial with complex roots. Is it? Till now, whatever things we studied till now in our 10th or inter, we just used a real part of a number. That is, we are going to, we have solved only real numbers ka equations. Here, we are going to start using complex numbers. Right? See here. So, my first root will be 1 plus 2i. My second root will be 1 minus 2i. Third root will be 4 and fourth root will be 2. Is it? Now, let me multiply in a tactful way. X minus 1 minus 2i. Here x minus 1 plus 2i. Here let me multiply x square minus 2x minus 4x plus 8. Now x minus 1 minus 2i. X minus 1 plus 2i, that is x minus 1 whole square minus 2i whole square. Is it? A minus b into a plus b into x square minus 6x plus 8. Right? Next. A minus b whole square. A square plus 1 minus 2x minus 2 square is 4. I square is minus 1. Here x square minus 6x plus 8. If I simplify everything and write, what do I get? X square minus 2x. Here minus 2 minus plus 4 plus 1 is 6. Right? This is the equation with this 4 roots. Right? Let me multiply all these. We will get in the form of a degree 4. X square into x square is x power 4 minus 6x cube plus 8x square minus 2x cube minus minus plus 6 2s are 12x square minus 8 2s are 16x plus 6x square minus 6 6 are 36x plus 8 6 are 48. Is it right? So x power 4 minus 6 minus 2 is minus 8x cube, and the next 12 plus 8 is 20, 26x square, and here minus 16 minus 36, that is minus 52x plus 48. Okay, you have to cross check each and everything. If you have any mistakes also, that's okay, but make sure that you don't do any kind of mistakes. Is it okay? Is it right? So this is forming a general equation when 2 or more roots are given. Yes. So how do we find the roots? How do we find the relationship between the roots of a higher order equations. Shall we do now? Let's do. Now just tell me, what is sum of roots and product of roots for standard equation? Let me say ax square plus bx plus c. Let us say alpha and beta, then the sum of roots is minus b by a. Alpha beta is c by a, isn't it? So what if I increase the number of roots? Let us say alpha, beta and gamma. Alpha, beta, gamma. That is ax cube plus bx square plus cx plus d. Then how do you remember this? What are the different parameters, or what are the different variables here? Here for sum and everything, we will say these parameters as S1 and S2. Remember this, right? Next, here also we'll have, since it is degree 2, we'll have only two relations. If it is degree 3, we are going to have 3. Here it will be like alpha plus beta plus gamma, alpha beta, beta gamma plus gamma alpha here, alpha beta gamma. Is it? So what is the formula? Here if you observe b by a, c by a. Here also b by a, c by a and d by a. But only thing is minus will be like one after the other alternatively. Done? Is it okay? Then this is the basic formula you can easily remember. What if the degree is increased? Right? So to generalize this nth equation in the form of equation, we will just write the roots as alpha 1, alpha 2, alpha 3 and so on up to alpha power n for a equation of nth order. Then their sum is given by summation alpha 1, right? And the next S2 is given by first and second. Let us say alpha I and alpha j, okay, or else anything is fine, right? Next, if I take summation 3, it will be like alpha I plus 1, alpha I plus 2, something like that, right? However it is, let us say here the roots are alpha 1, alpha 2, alpha 3. Then what about this? Alpha 1, alpha 2, alpha 2, alpha 1 plus alpha 2, alpha 3. Isn't it? So that's how we will simplify this kind of equation. If I say it is only degree power 4, then what do we get? I have only 3 rows, I will have only 4. Or else let me do this. For 1, alpha 1. For 2, it is like alpha 1, alpha 2 and so on. For 3, this is like 1, 2, 3. If it is for 4, it will be only alpha 1, alpha 2, alpha 3, alpha 4. That's it. No more increments, because the last term itself is only single thing. We are multiplying all the roots. Is it okay? Just a basic idea. If you understand this, we can solve most of the problems. You need not worry about this nth order. Clear? Shall we do a few problems of this relationship between the roots? Let's do. Look at the next question here. He gave if 1 alpha are the roots of this particular polynomial, then he is asking us to find alpha. There are multiple ways to find the alpha. That is, when we used to do our polynomials kind of chapters, just we used to substitute one of the factors and find it. But there it is simply a quadratic equation, so it is very easy to solve. But here it is a cubic polynomial. Is it easy to solve? Until and unless one root is known, we can't find any of the roots. Okay, so just for a casual simplification, let me compare it with ax cube plus bx square plus cx plus d equal to 0. What is a? A is 2, b is 1, c is minus 7 and d is minus 6. Is it? Fine. So I have 3 roots. Can I find S1, which is alpha plus beta plus gamma, which is minus b by a? Yes, right? So what is alpha 1 plus 1 plus alpha is equal to b is minus 1 by a is 2. 1 plus 1 is 2 plus alpha is equal to minus 1, but just substitute it there, transfer it there. It will be like by 2 minus 1 minus 4, therefore alpha is minus 5 by 2. Right? Anything else to remember here? Anything difficulty in remembering? No, right? So simply we have to remember the sum of the roots or else the product. Right? Fine. Look at the next question. The product of roots is 9. Then he is asking us to find a for this equation. Done. So if I compare it with standard equation, I will get it as ax cube plus bx square plus cx plus d equal to 0. What is a? A is 4, b is 16, c is minus 9 and d is minus a. Done. What is the formula for product of roots? Product. For this it will be like S3, which is alpha, beta, gamma, that is equal to minus b by a, c by n minus d by a. Done. Fine. Which is given as 9. What is d here? Minus a. What is a? 4, that is equal to 9. Therefore a is 36. Is it okay? So the main thing we have to remember is these formulas. Clear? Shall we move on to the next problem? Let's do. Look at this question here. He gave alpha, beta, 1 are the roots of this particular cubic polynomial. Then he is asking us to find the values of alpha and beta. Till now the problems which we did, in which there was only one variable, either alpha, beta or a or some other thing. But here we have two variable roots. So let us use the basic S1, S2, S3 and find the values of alpha and beta. Is it? So let me first write what is a? 1, b is minus 2, c is minus 5, d is 6. Done. So there are three roots. So I can write S1, S2, S3. Is it? So that is alpha plus beta plus 1 here, alpha beta, beta into 1 plus 1 into alpha. Here alpha into beta into 1. Is it okay? Now here it is minus b by a, here it is c by a, and here it is minus b by a. Is it done? So let me write this like alpha plus beta is equal to 2 minus 1 is 1, and here alpha beta plus alpha is equal to minus 5, and here alpha beta is minus 6. Done. So we have to simplify any equation from this. So let me take this and this. Okay. Now you can solve it in various methods. You can take factors, you can substitute this in here, or else we can use some other formulas like alpha minus beta whole square can be written as this relation. You have to remember. Let me tell you that. First, see here, alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta. I think we learned this in our quadratic equations also, right? So if I want alpha square plus beta square, I will just add it. If I want alpha beta ka value, I will subtract it. So these both will get cancelled. Here alpha plus beta whole square plus alpha, minus alpha minus beta whole square is equal to 4 alpha beta. Done. Now just tell me, can I write alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta? Yes. So what is alpha plus beta whole square? 1 minus 4 into alpha beta is minus 6. It goes like 1 plus 24, which is 25. Therefore alpha minus beta is 5. Done. I got alpha plus beta. I also have the value of alpha minus beta. Can I add those both? Yes. So if I add these both, I'll get 2 alpha is equal to 6, alpha is 3. Then if alpha is 3, what about the value of beta? If I substitute in 1 or 2, let me take this direct second equation. Alpha beta equal to minus 6, alpha is 3, therefore beta will be minus 2. Is it right? What did we do here? First he gave 3 roots, so we took sum product in order to solve this equation. Yes, then we can get the values of alpha beta here. Clear? What all we learned today? We started with the basics of what is theory of equation. Then we had a minute introduction about the higher order polynomials. Done. And then we did a few problems of relationship between their roots. Okay, fine. This is for today. Let us meet in the next session with the more problems of theory of equation. Thank you.